Welcome to this session, which is entitled New Guidance and Best Practices on the Security of Smart Built Environments with the Internet of Things Security Foundation. I am chair of the panel today. My name is James Willison. I'm co-chair with Saab Sembi of the Smart Built Environment Working Group. Today we have Nick Morgan from the Building Owners Working Group, Tony Wood from the Manufacturers Working Group, and Dave Cooke from the Facilities Management Working Group. We are also having some question and answers at the end and a breakout session which includes Saab Sembi, Jason Shaw and Michael Monaghan, which follows with a 20-minute time period for that. So we do warmly welcome you to join us at that point. We also are keen to demonstrate that it's been a process that's taken almost a year now to gather this documentation together. It's taken from January 2020, when we had a workshop where we agreed that we would form 4 subgroups to represent the building owners, the manufacturers, the facilities and the installers. Since February we have met bi-weekly and we have had between 3 and 8 members in each of the groups. We all have a commitment to write content in our specialist fields. We have therefore produced a comprehensive set of guidance and best practices which includes case studies and references other works in this area. We have had together a regular review process and updated our content over the months that have passed. We have had meetings and emails, and we now have 2 documents with over 20,000 words and 1 at 13,000 words. We are set for a publication in January 2021. Now today we have leaders from each group who will highlight the value of this content and show how it complements others. And if we need not have any other specific example, I think we should look at the case in September this year where a woman was rushed to a hospital in Düsseldorf University and she could not be treated because of a ransomware attack. It was very sad that she had to be taken to another hospital, and on the way she died. This just demonstrates to us how important it is we look at this area and we come up with challenges, solutions and recommendations, and this is exactly what we've done in our documentation. And while we consider the relevant work by CPNI, NIST, ETSI, all on the areas of cyber physical security and all highly commendable, we have taken the challenge to look at the smart built environment and how these different areas can respond. And in this case, I would ask you to join us in the breakout group which follows. We look forward to seeing you there and we wish you a very happy conference. Thank you. And now I pass on to our colleague Nick Morgan, who will take us through the building owners' response and what they have come up with and what we think is good advice for you.
Thank you, James. Hi, I'm Nick Morgan, the Building Owners Subgroup Leader. The desire for buildings to be smarter, driven by tenant expectations, enhanced operational efficiency, and building information modelling, or BIM, has resulted in a convergence of ICT network infrastructure and operational technologies. Whilst this convergence has the potential to bring many operational benefits, failure to secure either of these environments can introduce inherent information or cybersecurity risks. The threat landscape has also broadened with the introduction of IoT devices and connectivity to IoT platforms to collect data, produce analytics, and automate responses to environmental changes. The Building Owners Working Group have produced a guidance and security best practice document aimed at landlords and property managers to help raise awareness of the risks and threats associated with smart built environments and how they can be mitigated at various stages of a built environment's life cycle. A smart built environment collects data from lots of disparate data sources, such as IoT sensors, heating, ventilation and air conditioning, lighting, CCTV and access control systems, often all connected on a converged ICT network. This data is then channeled through an IoT gateway and sent to a remote IoT platform where it can provide insights into a building's environment and occupancy via mobile apps, web portals and API connections. Because of this, building owners, landlords and property managers need to apply a holistic approach to securing all of the elements that make up a smart buildings ecosystem, such as selecting hardware that has embedded security or meets the IEC 6244 standard, an area covered further in the manufacturer's document, ensuring converged ICT and OT environments are secure by design, including scheduled security patching in maintenance contracts, and reviewing third-party remote access and privileged account management. Another key area covered in the document is supply chain due diligence to assess the security posture of any suppliers involved in the design, installation, maintenance and operations of ICT, OT and IoT systems. Most organisations rely upon suppliers to deliver products, systems and services, but supply chains in smart built environments can be large, complex, or involve many suppliers and subcontractors doing many different things. A supply chain attack is a cyber attack that seeks to damage an organisation by targeting less secure elements in the supply network. So there is a clear need for property managers to understand the security posture of their supply chain, particularly if the supplier has routine privileged access to data or systems. As referenced in the document, the NCSC have published a series of 12 principles that can be applied to help property managers establish effective control and oversight of their supply chain. It's often said that security is everyone's responsibility. When it comes to securing smart built environments, collaboration and defining responsibilities between various supply chain stakeholders is key, including hardware manufacturers, property development teams, system integrators or installers, facilities management teams, building managers, and information security teams. This joined-up approach to security will ultimately help to bridge any security gaps and help make built environments not only smart, but also secure. In the document, we cover a broad range of security-related considerations from a property manager's perspective, but I feel the main areas of focus can be summarised in 5 steps. Step 1 is for a property manager to understand the definition of a smart building and the current and desired smart maturity level. This is crucial in understanding how the technology in the built environment may mature over time and the relationship to cybersecurity. Step 2. Collaboratively implementing good security governance between stakeholders and following a common security governance framework. Step 3. Understanding who and how the organisation will manage security risks to the environment so that everyone is clear on their responsibilities and where additional support will come from when needed. In most cases, additional support and guidance can be provided by the property manager's information security team. Step 4. Applying security by design to all ICT, OT and IoT environments and carrying out supply chain due diligence to determine the security posture of your suppliers. Step 5. Secure maintenance, operations and ongoing risk management throughout the built environment's lifecycle. That's it from me. Many thanks to James Willison and Saab Sembi, the Smart Buildings Working Group co-chairs, and the IoTSF for the opportunity to speak today. I'll now hand you over to Tony Wood, the manufacturer's Working Group lead.
Thanks, Nick. Hi, I'm Tony Wood, leader of the Manufacturers Working Group. As a group, we took the view that products should be secure by design and should function securely straight out of the box. Products are often installed in a hurry, not always commissioned properly, and frequently left with default settings. As Nick has reminded us, security is everybody's responsibility, from building owner to end user, and so manufacturers have a part to play, ensuring that their products are secure by default, easy to commission and use, and applying sensible security controls within the product and its interfaces. In common with the other guides in this suite of guidance documents, we began by considering the overall system or system of systems in which this product is likely to be deployed, and what this system might provide in terms of inherent security. The operational environment will most likely have been considered at the system level, along with physical security, thus providing a first level of defence. From a manufacturer's viewpoint, we identified 4 broad phases of activity: initial product considerations, product design, product development, and product testing. In producing this document, our aims were to identify critical areas where vulnerabilities may get introduced, and to propose mechanisms to ensure that this doesn't happen. We also provide links to relevant supporting documentation to supplement this guide. We have made no assumptions about the maturity of the design and development team, but have sought to clearly itemise the steps that need to be followed from conception to product release. At the very start of a product's concept phase, we consider at a high level the overall architecture of the system in which the product will form a part, and the demands this may place upon the product. Is it part of a cloud-based system? What recovery mechanisms exist if the product or system suffers a malfunction? How dependent is it upon the other system elements? And is it able to function when other parts of the system have failed? We also briefly consider the supply chain. What does it look like? How complicated is it? And what are the key aspects of this that the design team needs to carefully consider? If parts of the design or manufacturing processes are outsourced, what safeguards are in place to ensure the integrity of the product? Whilst this is a topic in itself, we do propose a few questions that need to be considered. Before development starts, the product should undergo some form of security risk profiling, followed by a security risk assessment. The point of this exercise is to consider who the likely assailants would be, and what level of risk they represent. The level of connectivity has the part to play in this assessment, and the nature of that connectivity. If compromised, could the product be used as leverage into other parts of a wider system in which it plays a part? Is it connected wirelessly or by cabling? The accessibility of the product in its deployed environment also provides useful information in assessing its vulnerability, along with the numbers of the product deployed. Does it form a key element of critical infrastructure? Is it too important to fail or to be compromised? When considering a product for development, a set of requirements is usually compiled to define what the product is expected to do and what perceived market need it is seeking to address. Similarly, a set of security requirements needs to be defined to target the security threats the product is likely to encounter. But how are these requirements generated? Is it in an ad hoc manner, or have they been generated from a recognised and respected framework or standard? The latter approach is most likely to identify a comprehensive set of requirements based upon the product's intended use. It is also worth considering whether the product will require some degree of security certification to provide an indication that it is fit for purpose for its intended use. It may even be compulsory if the product is to be used in a very sensitive system, such as critical infrastructure or defence. While security requirements are a useful first step, they do not always cover every eventuality, and so we introduce the concept of threat modelling as an independent means of viewing and evaluating the product in its deployed context, a form of gap analysis. Threat modelling considers the interconnectivity of the product and its environment. What components does it communicate with, and what threats may arise from these connections? The product itself may consist of individual elements, each of which has some degree of interconnectivity. Are these links protected, or are they vulnerable? Could sensitive data be extracted if the product was taken apart and analysed? Once threats are identified, how are they neutralised, and what are the mitigations to achieve this? Are these threats realisable? Having established the requirements for the product, development can begin. and so the choice of hardware needs to be evaluated. There are many challenges that need to be faced. Performance expectations need to be balanced against cost. If the product is too expensive, it may not be competitive. But if the product is underpowered, it may fail to compete in the marketplace and soon become obsolete. Also in the mix is the security of the product, and security is beginning to become a key issue in today's world. With vast quantities of data being generated and passed around, ensuring the integrity and confidentiality of that data is becoming more important. All this puts additional demand upon the processor. Can it cope? Or is some form of crypto accelerator required? Life expectancy of the product is not to be underestimated. What would be the expectation for it in, say, 5 years' time? Choices made now will greatly influence how secure the product will be from this time on and into the future. Some security features can only be established at production time, and are almost impossible to implement as a firmware upgrade in the future, so making the correct decisions is important. As for hardware, the firmware the choices made initially will greatly impact the security of the product going forwards. The choice of an operating system, for example, will determine the degree of flexibility the product is likely to exhibit in the future. Firmware upgradability is an important feature that needs to be carefully considered. How secure is the proposed upgrade mechanism, and how easy is it to implement? This will be influenced by the connectivity of the product. Can it be performed automatically, or does it require manual intervention? There are many things to consider. The use of open source code speeds up code development, but may be a vehicle for introducing vulnerabilities into the product. Security controls may have been implemented, but have they been done correctly? What tools are used to ensure that the implementation code is robust, and that the security principles such as defense in depth, least privilege, etc. have been followed? Once the product is close to finalization, the question needs to be asked, is it really secure? Have we implemented the controls correctly? Have we considered the whole product's attack surface? Security testing, or pen testing, can be extremely helpful in this regard, especially if carried out by a team that is independent from the development team. However, we also make the point that evaluating the architectural design of the product needs to be considered before development starts, and pen testers can play a useful role in this regard. Bad choices made up front are very difficult to rectify later. The intention of this guide has been to provide advice on many topics relevant to product development. We realise that for many of these we can only scratch the surface, and so we have sought to provide links to reference materials that provide in-depth knowledge of many of these subjects. It has been a privilege to participate in this working group, and I would like to thank the IoTSF for this opportunity, and also Saab and James as the chairman of the Smart Environments Working Group. Our final presenter is Dave Cooke, who leads the Facilities Managers Working Group. So Dave, over to you.
Many thanks, Tony, and hello everybody. I'm conscious that within each of our working groups we've been trying to address quite distinct audiences, and certainly within the facilities management team we've been very conscious of that audience and their specific needs. And within the working group we've had representation from facilities management professionals, from facilities management consultants, academia, people working on cyber security response, and indeed people working on software development within the FM community. So turning to the challenges which we've tried to address in our guidance, one of the key challenges has been to identify where responsibilities actually fall between the various stakeholder groups involved in maintaining and operating premises. Stakeholders involving building owners, building occupiers, managing agents, facilities management contractors, or in-house service providers, all of whom have an involvement in the maintenance and operation of the premises. And we've identified 6 building occupation models which set out those relationships. but there are a huge number of permutations. So we provided guidance on how people may go about identifying responsibilities. There are also some very complex interrelationships between the suppliers and maintainers of internet connected systems, smart building systems and the environment as a whole. And there's a huge range and diversity of systems themselves, ranging from very simple, perhaps CCTV systems connected across the internet, to complex systems running the building, looking after life safety and the maintenance of the environment, all interacting together in what is a very smart built environment. In all of this, one of the key challenges can also be identifying the relevant assets, often because the facilities management community are not responsible for the installation. Systems are handed over to them either from owners or managing agents, and information is not always complete. There's also a need to understand the threats posed by connection to the internet, and we spent a bit of time setting out what some of those threats are and how the current security posture of the organisation can be assessed. There's also a need for the FM community to access competent cybersecurity expertise, and we've provided some guidance on how that can be achieved. So looking at solutions that we've offered in our guidance, we based the guidance really around a process for assessing and improving security, which is applicable to organisations of all sizes and complexity. A fairly straightforward process, but each element in the process has some detailed guidance to support people working their way through the process. So gathering information, assessing where responsibilities lie, what assets are there, and any current policies and procedures that are in place. Assessing risks is really at the heart of starting this process. Where are we now? What are the risks? What's the organisational risk appetite? And where do we want to be in terms of improving the security situation? Planning to meet that response, taking action, and then reviewing and auditing where we've actually got to are the key steps in the process. And within that, actually understanding the attack vectors, what are the threats, how might they target our infrastructure and systems, and what might those potential impacts be, from compromising building management systems, possibly life safety systems, through to ransomware, extortion, or using the building infrastructure as a way of compromising the main enterprise infrastructure and data stored on it. One of the challenges, again, has been the accessing proper expertise for FM professionals where they don't have that knowledge themselves. In larger organisations, there may of course be an IT or information security department, and they can establish sound links with them and work collaboratively on tackling these challenges. But often that expertise has to be brought in. So we've provided quite a bit of guidance on how you select and assess the competence of advisors who may be helping you with these challenges. And the same is true of looking at your supply chain, people who are maintaining or installing your building management and building operational systems. And we've looked again at how do you assess competence in those particular contractors and suppliers. In addition to the process, we've also considered the life cycle of smart building systems and infrastructure, and what are the security issues which need to be considered at each step in that life cycle. And we've provided some guidance on how those issues can be addressed. We've recommended some standards and overall approaches to reduce exposure, and described in what I think is a practical, accessible way what best practice might look like. Also looking forward, we've provided some guidance on selection of new IoT devices so that overall security can be maintained. And finally provided access to sources of further advice and guidance should they be needed. So So all in all, I hope we produced a very practical, accessible guide aimed at the facilities management community, and one that will bring some significant improvements in overall security. So at this point, I'll hand back to James so we can address any questions. Thank you.